Hey guys, I'm Matt Grabert and this is Team Alpha. We programmed Farkle for our Engineering 6 Final Project.
Hi, I'm Mauricio Tavares.
I'm Juan Padilla.
And I'm William Hodge.
The goal of this final project was to create an interactive MATLAB GUI that allows you to play Farkle against another person on the same computer.
So here's our GUI. There's many different buttons to interact with. I'm going to start off with the rules button. When you click the rules button, a little link pops up that says click for rules. When you click it, it goes to our website that we designed to display the rules, any examples, and the different scoring combinations of the game.
Once you understand the rules, you can start by playing the game. First off, click the roll button. This will simulate 6 rolling dice. Next, look at the dice that appear on the screen and choose the scoring dice. Here we have a 5, a 5, a 5, a 5, and a 1. These are all scoring, so we can pull them aside by clicking the checkboxes. The 3, if we want to risk it and roll again, we can click roll. We did not get a scoring dice in this case, so here we Farkle. As explained in the rules, when you Farkle, you get 0 points. That is indicated in the top left corner under the player 1 box where it says 0. Before we Farkled, the scores added up to a cumulative score, but once we Farkled, it knocked that score back down to 0.
So the goal of the game is to reach 10,000 points. As you can see, player 1 is really close and he can win in this turn. You'll select these scoring dice and then submit them. And then the animation pops up at the top and you can hear the audio that we added.
So in this case, if you select dice that are not scoring, for example this one, the 4, we have 1 4, 2 4, but no 3 4, so this would not be a scoring dice. So the check-in feature works in both directions. So here we can uncheck it and then we can submit it.
So we also have a spreadsheet where we will be sending the scores throughout our game to. When you roll it, you select your scoring dice and submit it, it will go to the spreadsheet. When you hit the exit button, it will erase those scores so you can restart it when you start a new game. So now we're going to talk about our code, and this is the opening callback for the GUI. First, it initializes the backgrounds of the buttons to be blank. Then we set each of the players' scores to 0. Then we set the initial playing turn to player 1, and we turn the submit button off. That way it's not able to be accessed until you click the roll button. Then we initialize our global variable counter, which will help us in switching between each player's turn. We then coded how we connected our spreadsheet to our code and initialized the 2 columns to be player 1 and player 2, where we'll be storing the different scoring. Next, I'll talk about our roll button callback. First, we initialize the string at the top of the GUI to read Team Alpha. We then turn the submit button on so you can submit your score once you select your dice. We then initialize an array of image files so that we can index into them for our animation. We then have the sound that plays when you start the animation. We initialize our for loop, and then we index into the array of images in the following way. We first get a number between a random number between 1 and 6. Then we index into that array. Using that number, it selects a random image file and sets that to the background of each dice. Each of these check values here will take the value property of the checkbox, and there's a branching case to find whether or not the checkbox is checked or not. When the checkbox is checked, it will not roll that window. And we have the if case for each of the dice. So whatever dice you select with the checkbox, it will not roll when you click roll.
This is the beginning of the function submit button. First, we check and get the values for each checkbox because we're going to later use them in the branching. Here we can see the example of the first push button. And what we basically do is, if it's checked, then we will get the value of the dice using a number that is attributed to each dice window. And we pretty much wrote that code for each dice window.
This is the code that scores the 5s. For every dice that is equal to 5, you add 50 points to the total score. This is the code that scores a straight. The first statement checks if the array contains 6 dice because it can only be rolled on the first roll. Then the values are sorted and converted into a string to compare with another string array 1 through 6. If the two arrays match, a straight is worth 3,000 points. This code right here addresses the scoring for the 1s. The 1s are similar to the 5s, but in this case, for every 1 you get an additional 100 points.
This is the code to checking if there are 3 pairs. First, we must make sure that the array is of length 6. Then, we sort the array so that we can check that the first value is equal to the second one, the third one equal to the fourth one, and the fifth one equal to the sixth one. If this is true, then the output is 1500.
This right here is the code for scoring multiple of one number. In this case, it's 3s. For every 3 you get, the variable is added by 100. If at the end, this variable right here, output 3s equals 300, you know you got 3 3s and are given 300 points. If you have output 3s equals 400, we know you have 4 3s. And additionally, if output 3s equals 500, you know you have 5 3s. This code is very similar to 2s, 3s, 4s, and 6s, and the score is accordingly adjusted.
This is the code for checking if you have 2 triples. First, we make sure that the array length is equal to 6. Then we sort the array, and this if statement checks that 5s and 1s are not part of the array. Then we make sure that the first, second, and third value are all equal to each other, and that the fourth, fifth, and sixth value are equal to each other. If this is all true, then the output is set to 2500.
Here's where we add up all the outputs of the scoring combinations. Once you find the output, you will then test whether or not it's player 1 or player 2's turn, which we do with this mod statement. This checks whether or not it's odd or even. If it's odd, it's player 1's turn, and the output will go to player 1's menu. If the mod statement is even, then it will go to player 2's menu. Here's where we connect our spreadsheet to our scoring combinations. And here's where we transfer that data to the spreadsheet. We use the counter global variable so that we can display this data on the spreadsheet after each turn.
This part of the code checks whether or not player 1 or player 2 has won the game. In either case, an animation will play saying that the player has won with a sound file in the back. After that, all the images reset and the turns switch. When you click the exit button not only resets the GUI but also resets the values in the spreadsheets. Next, we have the checkbox callbacks. We initially use the value property so we can use it in the branching. If the box checked, it turns the corresponding button off. And if you uncheck the box, it turns the button back on. And this is the same for all checkbox callbacks.
The Farkle button starts off with an audio, then it shows an animation. It also switches between the players and resets the dice buttons.
This is our rule button callback, which can link you to our website where you can find any information about our game.
I am now going to introduce our object-oriented programming element. We first initialize our class with one property called score. Then, in the Farkle opening function, and here, in the submit button callback, we initialize our variable to our class player. That way, we're able to set a score value to the score property of the player.
Hey guys, thanks for watching. We had a blast making this game. Have fun.